success of space colonization will depend upon it.
The ambitions to settle somewhere out there go right to the core of our existence.
Compelling reasons to colonize space are to see if we can expand the range of our activities beyond the Earth, or are we really confined to the Earth? I think that's an important question we need to know the answer to. The second one is, what's the role of life? We have on this Earth a phenomenon called life. Is it destined to spread beyond the Earth? We are the species that can cause that spread.
Carl Sagan, the great noted astronomer, once said that we should be a two-planet species. That is, we should colonize one planet and also have the Earth because, for example, the Earth is in the middle of a cosmic shooting gallery. There are comets and meteors whizzing all over the place on a scale of hundreds to thousands and millions of years. And we need a spare planet because it's simply too precious to put all life on simply one planet.
In the vastness of space, there's one destination above all others that stands out as prime real estate for colonization.
Laythe.
Mars is the grand prize of the solar system. It's the closest planet which human beings can settle. It's the closest planet that has all the resources needed for life and civilization.
Mars, the fourth planet from the Sun. It's about half the size of Earth, and at its closest pass is roughly 35 million miles away. The ancient Romans associated its red color with hostility and named it after their god of war. But far from hostile, Mars has the potential to be the most hospitable planet after the Earth. The gaseous outer planets offer no solid ground. Among the inner planets, Mercury is too scorchingly close to the Sun. And Venus, though similar to Earth in size, is baked to 870 degrees Fahrenheit by a runaway greenhouse effect. It also has an atmospheric pressure that would crush any would-be human settlers. Mars does have its own pitfalls. It actually has extremely low atmospheric pressure, which would cause your blood to boil and then freeze. But a pressurized spacesuit can overcome that danger. And while it's cold on Mars, with typical daytime temperatures 20 to 40 degrees below zero, humans could easily survive wearing proper protection. Most important, the red planet, with its carbon dioxide-rich atmosphere, seems to have the natural resources we would need to keep a colony running.
On Mars, we have carbon dioxide from which we can extract oxygen and make fuels from it. There's water vapor in the atmosphere and also in the polar caps. The soil on Mars, the regolith, has the minerals and various compounds we need in order to set up a colony on Mars.
Today, Mars is a frozen desert. But photos taken by space probes show clear evidence of erosion. This means that not only did Mars at one time have water on its surface, but also that it may have once supported life. Finding evidence of previous life, even microscopic organisms, might make the difference between whether we establish a short-term base or a more permanent colony there. Long-range mission planning is already underway at NASA. The space agency plans to return man to the moon by 2020 as a stepping stone to a Mars mission.
One of the major themes for the lunar exploration is called Forward to Mars. And within that theme, we'll be constantly thinking about how we will operate on Mars. The astronauts will be involved with studying how humans react to the planetary environment, how hard they can work, how much sleep they need, how much entertainment they need, how they will relate to mission control. We need to learn to deal with all of these issues that come with people living in far-reaching environments.
An important step in preparing for a long wilderness trip is testing the gear. Setting up everything in a local spot, even in your backyard. Make sure you've got everything you need and it all works. In that same way, setting up a base on the moon is a practice run for setting up a base on Mars. We learn what to do, we learn all the equipment we need and how it works. We get everything working just right.
Everything includes versatile robotic machines like Athlete, which stands for All-Terrain Hex-Limbed Extraterrestrial Explorer.
Athlete is designed to carry cargo on the moon or Mars. The most important cargo we could carry would be a habitat. That's usually the largest single piece of any human mission.
But Athlete can do much more than just haul cargo. Each side of the machine is equipped with high-definition cameras that give a 360-degree view of the surroundings and display it to an operator based either on the planet, in an orbiting spacecraft, or back on Earth. And each limb is like its own self-deploying Swiss Army knife.
One of the things it can do is take one of its limbs and grab a tool out of a tool holster and use that tool to excavate. So we have built scoops and drills and grippers and other tools. One of the most interesting things is that if a leg were to fail on Athlete, the two adjacent legs could in fact grab tools and disconnect the one leg that's failed and amputate it and leave it on the surface.
With equipment like Athlete, astronauts will be able to establish a long-term base on the moon and test how self-sufficient they can be. Only then, according to NASA, will we really know if we're ready to go to Mars.
The real acid test of our understanding how to live in space will to take a crew of, say, 6 people, put them on the far side of the moon where they cannot see the Earth and have the psychological disadvantage of not being able to connect to the Earth, and see if they can exist for a year on their own with the systems that we designed for them. If we're able to actually do that kind of a test and experiment, then I think we will have checked the box that, yes, we're ready to move out into the solar system and settle more difficult regimes such as the planet Mars.
The moon's close proximity to Earth, about 240,000 miles, only a 3-day trip, makes it a convenient proving ground. But its environment is vastly different from Mars.
Mars compares to the moon as North America compared to Greenland in the previous age of human exploration. I mean, Greenland was closer to Europe. Europeans got there first, but ultimately it was too poor an environment for a new branch of human civilization to really develop in. Same with the moon. The moon is closer to the Earth. We got there first, but as a place for settlement, Mars is a much better place to go.
Mars has more water and other useful natural resources than the moon. It also has an Earth-like day-night cycle that lasts only about 40 minutes longer than ours. That's why the Mars Society, an organization of scientists, researchers, and NASA personnel, thinks we should skip the moon entirely and head directly for a rendezvous with the Red Planet.
Mars Direct is a plan for sending humans to Mars without the need for futuristic science fiction spacecrafts and without the need for a lunar base.
The Mars Direct mission plan proposes 2 launches. The first sends an Earth Return Vehicle, or ERV, to Mars.
Land this on Mars, and then you run a pump and you suck in the Martian air, which is mostly carbon dioxide. And we react that carbon dioxide with a little bit of hydrogen that we brought with us from Earth to produce a large supply of methane and oxygen rocket propellant. So now we got a fully fueled up Earth return vehicle sitting, waiting for us on the surface of Mars.
The second launch sends a crew habitat module to Mars. After conducting their mission on the Red Planet, the astronauts board the ERV to return home and leave behind the habitat module.
Each time we do this, we add another HAB module to the base. And after a few missions, we've built the beginning of the first human settlement on a new world. There is nothing in this that is beyond our technology. It's simply a question of having a little bit of moxie, a little bit of will.
But to skeptics, the Mars Direct mission plan is a non-starter.
If we tried to go to Mars directly, the first step would be something like 20 years of preparation and testing, and at that point, the public will get very bored with the idea of going to Mars. We believe that we can get to the moon in a time frame where the public will be heavily engaged in human exploration of space, and that will enable us to get to Mars in some sense faster because we'll have more confidence and we'll have less risk to human life.
Getting to Mars, whether by direct mission or only after further lunar exploration, is just the first step towards colonizing the planet. But getting there will be as challenging as living there. Surviving the journey will be the ultimate test of human endurance. The trip to Mars is 6 months long. That's when the Earth and Mars are at their closest alignment, making it the best time to depart.
Earth and Mars both go around the sun, but they go around at different rates. And every 2 years, Earth and Mars are on the same side of the sun, and so then that's when it's close. And then it only takes 6 months to get there. When Earth and Mars are on opposite sides of the sun, forget it. You're not going from one planet to another. Not with the technologies we've got. You got to wait for warp drive or something like that.
There are new hardware elements that need to be developed to enable a human flight mission to Mars, but no new technology. Everything we need to make, we know how to make. We are much closer today to being able to send humans to Mars than we were being able to send men to the moon in 1961 when Kennedy started the moon program. And we were there 8 years later.
0, all engine running.
The new hardware will include the Ares, the next-generation rocket that will launch man to the moon and beyond. The Ares should be ready for liftoff within a decade. It's about the size of the Saturn V of Apollo fame. Taller than a 36-story building, the Saturn V was the largest and most powerful rocket ever launched, capable of delivering a 53-ton payload into lunar orbit. But the Ares, using boosters derived from the space shuttle, will be able to muscle an extra 22 tons of cargo on each trip to the moon.
So if you have very large rockets, you can have fewer launches in order to assemble the spacecraft that goes to Mars. So the large rocket is really a product of the desire to ultimately look at Mars in our exploration scenarios.
New hardware will also include Orion, the crew vehicle. It will be more than 2.5 times the volume of an Apollo capsule. On its missions to the moon, Orion will dock with a lunar lander sent into space on a separate launch. Unlike Apollo spacecraft, Orion will orbit the moon unmanned, while lunar explorations take place. The astronauts will redock with Orion for the return to Earth. This new crew vehicle will borrow much of its hardware from the space station.